Hey YouTube, welcome to Polydev tutorial series. In this video, I'll be teaching you how to create Cypher's trap in Unreal Engine using C++. Cypher is a character from Valorant. Valorant, for those of you who don't know, is a brand new tactical shooter game and is very fun to play. This video will be split into two parts and is created more towards newcomers who have little experience in using UE4 and in programming. These are the requirements you need in order to follow and understand this tutorial. I will be using UE 4.25 version in case anyone is wondering. Before we start coding, I'm going to show and break down the mechanic itself. Cypher's trap ability is called Trapwire. In this ability, you throw a trap between two walls, and whenever the enemy walks into it, you can not only see them through walls, but you can also slow down their movement. And a few seconds later, it will also explode, causing their camera to go dizzy. But for the sake of the simplicity, in our tutorial, we'll only be making the trap, and we'll be making it so you can see them through a wall, and we'll be slowing down its movement. We won't do the camera effects and stuff because we're not making an online game, we're only making it locally, so I'm just going to keep it simple. We can break down this mechanic into two parts: the trap itself, which shows enemies upon activating, and wall detection, which will happen when player activates the ability. In this video, we'll be mainly focusing on wall detection part. The wall detection is pretty simple. We're going to draw a line from player's viewpoint, and when that line hits a wall, we will draw another line from that hit point towards the direction that the wall is facing. Once that second line hits another wall, that means we have a valid location to place the trap. As for the creation and placement of the trap, I will be covering it in the next video. Before starting the project, I would like to go over the design pattern I will be using to create this mechanic. To create this mechanic, we will use a design pattern known as composition. Composition is when a class object, such as the player or character for example, uses or relies on another class object to execute its behavior. So in this tutorial, we will be creating a Trapwire ability component which will take care of detecting walls and placing traps. When this Trapwire object is added to the player class as a component, then the player will automatically have the ability to detect walls and place traps. This will give us flexibility and also allows us to decouple the ability behavior from character behavior. So basically, it allows us to add or remove behavior to any player that we choose. Now, without further ado, we'll get into the project. We're going to launch Unreal Engine. Make sure to choose the game project, choose first person, and make sure to choose blueprint class. And we're going to name it as Valorant Tut, so short for tutorial, and we're going to create a project. Once we have the project up, we're going to right click, create a C++ class, and choose actor component. We're going to name it ability. Make it public, and we can create a class. Quick heads up, if you want to change which IDE you want to use, you can go into edit, editor preferences, source code, and there you can change which IDE you want to use. Okay, now we're going to go into our C++ class, Valorant Tut, into public, and then we're going to right click our ability class and create a class derived from it. And we're going to name it Trapwire, make sure it's public, and we can create a class. If you guys do not see the ability class then simply close your project and reopen it. By creating a class derived from ability, what we're doing is we're creating a class that inherits from ability. By inheriting from ability, every class that is derived from this ability class gets all the functionality and data that the ability class contains. So for example, in Valorant, every ability has a cost and amount of times it can be used. So if we put the data regarding the amount of times the ability can be used and its cost inside of the ability class, now every time we want to create a new character's ability, we can just derive it off this ability class, and that new class will automatically have the data regarding how many times it can be used and the cost. Okay, once we have the trap.cpp and trap.h open, we're going to make some basic functions, just like in their parent class. They have begin play and tick. These functions are very crucial for our gameplay system. So first, we're going to copy them, Control C, and then go into the trap, and we're going to do Control V. But now, because these functions say that they're from ability, we need to make sure that this is from trap class and not ability class. So we're going to change these first. I'll make sure to put U in the front, because every actor component starts with U and every actor starts with A. Once you define these functions, you need to make sure you have them declared. So here in the trapwire.h, we're going to make a protected section. So once you have the protected section, we're just going to define these declare these functions as with virtual. And we're going to declare that override because we're overriding the function. For this function, we can just copy this section and paste it here, just to make sure it's quick, and then remove this class definition and make sure it's virtual. Make sure to put override in the end because we're overriding the function. And once that's finished, you can comment this as begin play and tick function. Okay. Once you finish commenting, we're going to go back into the Unreal scene. If you play right now, you realize that you can shoot some projectiles. This is because it's a default template. It gives you the ability to, which is great. But what we really want is to shoot a line right from our camera to a wall, and we want that line to bounce off to another wall. So to do that, we have to go back to our Visual Studio, and we need to get the camera because camera is the starting point. So to do that, we're going to declare a player camera variable. You can do that by typing in the class, it's like forward declaration, and we can get camera component starts with U because it's a component. Once we're going to create a pointer to that component and call it player camera. Once you have the player camera, you go into the C++ and you have to make sure that you include camera's class files, because without those files you cannot access the camera's functions. So you hash include right. So if you include camera component, this is basically will give you access to the camera's functions, and anytime you want to include new components of Unreal Engine framework or actors, or you can just simply search them in Google. You can go into Google and you can type in UE4 and whatever component you want, and you can go into the access, the documentation, and you can see here that it tells you to include this, which you can take and copy paste into your include file, and then that's pretty much it if you want to include any of your any of the different components that you might include. Alright, now let's write a first function, which is drawing the ray trace, or you can also call it as a line trace, which will detect walls and give you the location of the walls. So to do that, we need to create a function. We're going to call the function detect walls, because that's what the function is going to do, and it's going to return true or false. So it'll return a boolean and it'll be called detect walls. Once you have this, if you're using Visual Studio Community version like 2017 or 2018 and not Visual Studio Code, you can just right click and do quick actions refractions, and you can create a definition inside the CPP like so, and it will automatically create one. So if I go back into the CPP file, you can see that it already created one and also returns as false by default, which is great. So first, what we're gonna do is we're gonna first make sure that we have the camera component, because right now we just made a pointer to the component, but we don't actually have the component itself. So time to get the component. So how we can get the component is we can just say player camera equals, and you can get the owner of this component, so whoever's using this component or has this component, and want to check if it has the camera component. So you're going to find component by class, and it's going to be camera component. That's a type. So to write camera component, you have to prefix it with U, because all actor component starts with U. You're going to say U camera component. You actually have it right here, and it's going to find a camera component for you. And once you have that function set and ready, the next thing we have to make sure is to get input systems, because we can't actually do these ray traces without having an input. Once we have an input, when we do the input, it's going to draw the ray trace. So we also need an input component. So we're going to go back to the H file, type right near the player camera, we're going to type input pointer, say input component, make sure to prefix with U because it's a U component. And once we do that, we're going to go back into the CPP file and we're going to define it. So to define the input component, we need to get the input component from the controller, and we can get the controller from the world. So what we can do is first we need the world, and from the world we need the controller. So we're accessing the world and the input and the controller, so we need to include both of them. To do that, all you have to do is go into Google and type in controller. In going to the C++ API, it says a player controller. That's fine with us. And then we're going to make sure to add this. Include directly. Over here. So now we have access to the controller. The last thing we need is world, which is just if you go back here and type in world C++ API, you get the U world. And then that's where you just copy paste it again. Now that you have both of these, what you can do now is you can get the current instance of the world, and you get the first player controller. That's the one that you set in your game mode. And from the controller, you're going to get input component. And that's basically your input component. Now, once we have this input component, we might as well bind all the buttons that we need. So so how it works is we bind a button to a function, and so we need to make 3 functions. One function is to draw the line. So as Cypher, you can press C and you'll draw the line. And another function is to throw the trap, which is the mouse left click. And the final function would be to retrieve the trap back, which would be F. So that means we need to bind three functions to 3 buttons. So what we're going to do next is input component. We're going to do something called bind key. Let's just go for bind key for now, because you can also do bind action, but I'm just going to keep it simple and just put bind key. It requires some parameters, such as the key that you're going to bind and the function. Finally, it also requires your it also requires a reference to this component. So first, we're going to create the key and the function that it's going to be bound to. We can do it right here. Call F key, and we'll just call it activate key. So this is the key that activates your ability, and we're going to create a function right here near detectables. We're going to call it void activate ability. We can just call it activate. We don't need to call it activate ability. Once you do this, you can just right click, quick actions or refractions, and create declaration definition, and it will create one in the CPP for you. Once the definition is created for you, you're going to go back to the bind key and first type in the key, activate. We might change it to key just so we know we don't get confused between these two. And go back, type in key. Then you tell it exactly what you want the button to do. So I want the key to be activated when it's pressed. So you go pressed, so this activates when it's pressed, and you need a reference to this component. And finally, you need the function reference itself. So you type in this for reference, and you have to type in the class as well. And from the class, you get the activate function, and that's pretty much it for binding. So we have to do this 3 more times. So I'm just going to copy, paste, and paste. All we need to replace now is this function and these keys and these functions. So I'm going to go back here and quickly create more keys. I'm just going to take this out real quick. Key, and now throw mine. I'm just going to call it throw key, and I'm going to call it fetch key. Now we know that they're keys. Once you've done that, you would probably want to also create the functions for them. Void throw. So this function will throw, and this function will help you fetch. Once you created those two, you can just right click them and create declaration definition and do the same for fetch. It might take a while to load, so I'm just going to skip this part. Okay, now that I created these functions in the CPP, I'm just going to quickly check. As you can see, you have your activate, throw, and fetch. Now you're going to go back here and change this to throw, right there. And this key is going to be throw key. Yeah, select it right there. And this is going to be fetch key. And finally, this is just going to be fetch. Now we have bound these to the functions, but just in case that this input component is not valid, meaning there was no controller that was spawned in the first place, we might want to complete it. We might want to protect the if the component is broken, this is not how you want it. So if you have a component that's not also it's likely to crash at some point. So we're gonna type in is valid, which is a function that validates, and we're just going to take this, paste it here, and we're going to Control X and Control V, all of that, so that it's all in the validate. There you go. Once that's finished, we go to the next thing, which is finally to draw the line using ray trace. So to make a ray trace, we need the camera. So first, since the camera that we're getting from the player is a pointer to the camera, what if this component's on an actor that doesn't have camera? Then you're in big trouble because the program's going to crash. So first we're going to protect our camera component because we're going to use it to draw a line, and if camera is invalid, then it's very bad. So player camera. This is the one we need to check. We're just going to use Unreal's is valid function to make sure it's valid. And actually what we're going to do is we're going to check if it's not valid. So if it's not valid, we can just return false. We can just return Control X, Control V, and we can just return false. So now anything that happens beneath this function, beneath this if statement, is basically happening only if it's valid. Now we're going to create a ray trace. To do that, we have to create a ray trace from the world, and it's part of the world. So luckily we already added UWorld before from the engine.world, engine/world.h. Now we're going to get world instance, and then we're going to look for line trace by object. So there you go, that's line trace, sorry, that's multi. We're going to look for line trace single by object type. Now this function looks like it's going to return if it hit a boolean, so if it hits something or not, and it needs few parameters and it takes the parameters as references. So this means we have to create those parameters and pass it to this function, and it will take them as direct references. So to do that, we're going to first create the hit result, and then the start location of the trace line, which would be the camera point, and the end location, which would be the forward vector of the camera plus its location. And it requires F collision object params, which are basically what type of objects do you want to hit, like world static or other players, or what type of collisions. That's all you need. The rest is autofilled. So first we're going to create the hit result. Hit result right there. We'll create a hit. After this, we're going to need an vector. So all the structs and vectors are all they all are prefixed with F. So that's how you know if it's a struct. And I'm going to call this start. And this is going to be player's camera location. Camera, point to your accessing its members, and you're going to type in get location. Sorry, it's get component location. Now you have the start location, you need the end location. It's going to be players. It's going to be player's location, which right here you define as start location. So you can actually say start plus player camera forward vector. So you want forward vector. So you're gonna just type in get forward vector. And you're going to times the forward vector by distance. So this is going to be the distance for your first line that you're going to check the wall. So you need to know how much distance, which you're going to create a variable. You can create another variable here called, it's going to be a float. This will be a throw distance. So this is the maximum distance that you're going to be able to detect the first wall and throw the mine. So this will be throw distance, and we're gonna take that and times it right here, and this is going to be your end location. So that will be your start plus camera's forward vector times throw distance. We can give some value to this, like you can do 1000 point OF, that's float. Once that's finished, the last and final parameter you really need is to create a collision parameter. So for that, you're going to create F collision object params, and you're just going to call them Core params. Sorry, Core IntelliSense is a bit slow. Core params, and now you're just going to pass this all these objects into the ray trace. So to do that, we're just going to go one by one. So we're going to say hit. It's the first one it wants, and it wants a start location. We're going to pass start, and it wants the end location. We're going to pass the end location, and finally Core params. We're going to make sure that we're going to set Core params to detect some sort of wall. So here you can choose Core params dot because this is not a pointer, this is a normal normal variable, so we're going to use dot, and we're going to add object types. And what these are is basically collision channels for the object. Collision channels, enumeration, and we can choose whatever we want. If you noticed so our ray trace should only be able to detect things like walls and like static objects. So we're going to choose world static, which is the option right here. You can, if you want, you can choose other things like physics bodies or world dynamic things. It's up to you. So this thing has been added now, which means we'll be able to detect walls here. But if you want to detect things like these boxes, you can click on the box and come here and check its collision presets, and it will say it's a physics body, that's its object type. Whereas these walls are just default, like they would be default to world static objects. It does not show here, but if I type in custom, yeah, if I check it as custom, it will show that it's a world static. You can just it's by default world static, so that's its default. We're going to go back into the Visual Studio, and for now we'll only do world static. That's completely fine. So this will be our first line. So this will actually be Boolean. We're going to promote this into a variable as first hit. So this function returns the first hit, and now if we actually did detect the first hit, what we're going to do is we're going to draw a second ray trace from that first hit wall to a different wall. So if first hit is true, then we're going to once again draw another trace. But before we draw this trace, because you can't actually see this trace, we need to be able to see this trace. To do that, what we need to do is we need to draw a debug line, which will help us visualize the line when we're playing. So to draw a debug line, we need to include the debug header, which like I showed before, you can actually search up in Unreal documentation, and you'll have the include file right here. You just Control C and then Control V. Oh, sorry, not here. You do right in the header, and now all you need to type is you need to just type draw debug line, and you will see the function. It requires world, a start location, end location, and color, and it also requires lifetime and thickness. So for this, we're gonna first give the world, instance of the world, and then for the start location, we're actually going to start the debug line from the player's hand, or let's just say the gun. So we're going to go here and we're going to see what a gun has. Sorry, I'm just going to go into Unreal Engine. As you can see, we actually have a spear component that we can start the line from. So what we're going to do is we're going to give the spear component. So we're going to go back here, create location for the spear. So we're going to get the location of the spear. Debug start location is going to be, we're going to get the owner. We're going to find component by class, and this is going to be use spear component. And if you want to access any of the anything about the use spear component, you just do what I showed you before. Just go here, type in spear component, and it should come up right here in C++ API, and you can just include that. And now it recognizes it, and then just go back here, and sorry, you have to first make sure that the spear component, we're going to get the location, And once you have that, now that's your debug start. Debug start, and that's what you have. And for the end location, what we're going to do is we're going to take the hit, the result that we got from doing the get well line single line trace. We're just going to give an enter so we know. By doing the line trace, it actually modifies the hit object that we created, and it actually gives a location. So here we're going to type hit.location, and that will basically give the end location that we just hit. The next thing we need is an F color. We can just create an F color. Dot blue. We can just do that. And finally, for the rest, we can just press. We don't want it to last any duration. For any duration, maybe we want thickness as 1.5. You can just choose whatever. It doesn't really matter. And then once that would basically draw the debug line. Now we're gonna compile and check if it. To compile, you can just minimize this, go back to your engine and just hit compile, and that will compile. I'll be right back after it compiles. Alright, I have compiled and I seem to have gotten errors. So the error is basically it's a return error, so I forgot to return. Not all parts were returning, so it was returning false here. For now, we're just gonna say return false. Return false, and we can put that here as well if you want. It doesn't really matter over here. Once we do that, we can try compile again. So click this and it will compile. I seem to have gotten another error, but this error, it doesn't really specify which line. It just says error. It just says linker error. So this might happen for you guys as well, and this is mostly caused because of not including some modules. So it says these three functions, which are the input functions that we put, are not valid, because to make them valid, they depend on certain modules, and we need to add the modules in the project build folder. So we're going to go into the project build file, and right over here we need to include we actually include two modules, and they're basically Slate Core and Slate. So we're just going to do this. It's a string, so it's going to be Slate Core and Slate. Once you type this over here in the private dependency modules, you can go back and try compile again. Alright, my code successfully compiled. Now I'm going to go back into the trapwire.cpp. I can just remove this. This is, if it's it, actually it should return true. That doesn't matter. We're going to go back here, and we're going to first person blueprint, and we're going to our character blueprint. We're just going to wait for it to load, and then what we're going to do here is we're going to search for a component. We're going to type in Trapwire, and it seems like we can't find it. That's because we have to make sure that we go back to our file, and we need to include. We have to make sure that we have to include something in the U class, so it's actually we can find it in the blueprints. To do that, you can go back to your ability.h right here, and then here you can see that it's specified over here, and just copy that, paste it in here, and you just recompile again. Once it's recompiled, you now can go back into the blueprints and look for Trapwire. There you go. Now you'll probably see that there's no real options to choose any of your buttons, because before we assign some buttons in our code, That's because we actually haven't exposed it, just like how we exposed this component to the blueprints. We have to also expose our buttons, and to do that we're gonna type in U property, and we're gonna type in U property, edit anywhere, read, write, and that means we can actually choose this button. And when you choose this, what we want is basically this function. This will activate this function. When you press the button, this function is called, and what you want to do is you want to turn on the detecting walls. But to do that, detect walls have to be running every frame, so that you actually have to find the wall every frame. So what we're going to do is we're going to create a boolean about these detect walls, and we're going to call it is active. So when you press the activate key, it's going to call this activate function, and the activate function is going to turn this into true, because by default it's false, and it's going to turn it into true. And as soon as it's active is true, on tick, we're going to type in if is active. We're going to keep detecting, we're going to try and detect walls. And we're going to recompile it. Make sure this is closed, because sometimes if you don't have the blueprint closed, it doesn't compile properly, it doesn't update to your blueprint. So just in case, we're going to close this, and then we're going to compile. Hey, just a quick note, before you go ahead and compile, there's one thing I forgot to do, which was go back into your code and go into activate and actually turn on the is active boolean to true. Sorry, I forgot this before. And once you activate this, once you turn this true, it will become true here. And if it's active, it's going to keep detecting walls. Now we can go back and compile. Okay, so once you compiled your project, you can go back into the blueprint and click on your Trapwire. And if your Trapwire seems like different color, or it's a bit different, you can actually, if it looks big, buggy, and you don't see this on the screen, you can actually take it out and recompile, and then you can right click and go to asset actions, and you can reload them, or you can just open it and delete this, and again type in Trapwire. If you seem to have any kind of bugs which stops the UI from showing, it might happen sometimes. Sorry, so now you go here to the active key and activate key, and then you go and type capital C, close this, and you should have C here. And once you minimize this, you play and you hit the C button, and you realize that there's a little blue line. You can see a little blue line near your gun. I don't know if you guys can see it, but there's a little blue line that kind of bugs out. Sometimes it goes to the side of the screen, sometimes it might go on the ground. That's because if you're looking at a distance where you can't detect a wall, it automatically the debug goes to the 0 location, which is somewhere over there. But if it actually finds a wall, so if you go near a wall, you can see that it is detecting the wall, and the line might be very thin, which we can change, but you might also notice that the line is above the crosshair. That's because that's not the fault of the ray trace. It's actually the crosshair itself is too low in this template. It's made for projectile aiming. It's not made for hit scan aiming. So you're actually still ray tracing the middle of your screen. It's just the crosshair that's off. So what you can do now is you can go back, press escape to escape, and this is the plane. You go back into your code. First, we're going to make this bigger. We're going to increase the thickness. Maybe 3.0. Go back here. And just like we did this here, we're going to copy this in this header file that we created for Trapwire, and we're going to add this here to the throw distance, so we can actually increase the throw distance. And while we're at it, we might as well also put it for these keys so that we can change these keys as well. And I guess if you recompile now and if you to check, you might see something different. Alright, once it's compiled, you can actually go back in, and if this is updated, you can see these, and if you don't see these, just like I said before, you might have to take the blueprint out and then, recompile it and try refresh it, and once you do that, you should be able to see this number. Now I can set this number back to instead this as high. I'm just going to set the number so you constantly detect the loss, and this might have been set because you really don't want it. And now I'm going to type C again. Now if I press C, now even if I stand far away, I can see that my line is always detecting the wall. But we still have one problem, which is that line is not visible enough. It's too thin, and that's probably because I forgot one of the parameters. If I go back here, before the time I forgot to give the boolean, which is going to be false. And then once I do that, now if I recompile it, alright, now the recompile is finished. I test it. There you go. Now the line is very thick and it's detecting the walls. As I explained before, it's going to be above the crosshair because actually the crosshair isn't in the middle of the screen. It's actually a bit below. It's made for projectiles, so that's fine. But if you look up now, the line will automatically go down because you're just pointing to the sky. There's no wall there. But if you point to a wall that's within the distance of 10,000 units, then you'll detect it. Now that we can detect one of the lines, the next thing we have to do is we have to bounce the line off the wall that we're facing. To do that, go back into your code and you're going to draw a second line from here. So to do that, we're only going to draw a second line if we hit a wall. So after first hit, we're going to say if, and in this if, we can just copy the same one because we're still detecting another wall. So I'm going to copy. As you can see, do not copy this part accidentally because you don't need this. Once you copy, and you're going to check again that if you're hitting a second wall, only then this should turn true. You only detect walls once you detect the first hit, and you detect the second wall. So that's why we're putting in other if statements where we actually return true. But the only thing is the parameters has to be different. We can still use the same hit result, but now we need a new start location and a new end location. To do that, what we're going to do is new start location is actually going to be the thing that we hit before. I want its location, so that's going to be so it's going to be hit location. End is actually, this might be a tricky part. It's going to be hit dot impact normal. So what a normal is basically it will give you a direction that the wall is facing. So it's going to be impact normal times, this is asking for the end location now. So the end location, actually, we're going to create a vector and we're going to give it a end location, like how far do you want the line to bounce off the wall. So for that, we need to say second end. We can just say second trace end. It's going to be giving a location. It will be your hit location. Plus the way that the direction that the wall that you hit is facing, which is hit dot impact normal times wall bounce distance. So we're going to go back here and we're going to create a new distance right underneath here, bounce distance, and we're going to actually give it more so that we can actually detect one. Actually, let's just do this. Let's give it the same, but actually we're going to put this so we can actually change it in blueprints. to do that, I'm just going to take this again and I'm going to paste it here, and that would be bounce distance. That would be our second trace end. We can take the second trace end and put it here. We no longer need this. And once you have that, it's still only going to detect walls, so static objects. That's pretty good. Once you're done with that, so once you did hit another object, we're not only going to return true, but we're also going to draw another debug line to visualize the line. So it would be the same as these parameters, but it's going to be a bit different. Now, debug start is no longer debug start. We're actually starting from the location that we hit. It will be hit location. Sorry, you can't use the hit location because the hit location has been changed after doing this. Now the new hit location is the location of the second wall that you hit. So what we have to do is we can still do this. We can do hit dot. If you press start, trace start. So hit dot trace start. This will give you the location it's originally started from, which is the first object's hit location. Since hit has been again taken in as a parameter and its values have been changed, that's why we're saying trace start and not location anymore. Because now for the second wall, we're gonna say hit dot location, because now its hit location is actually the second wall, not the first wall anymore, since this function changed its values. Once we do that, this will draw the second debug line. But what if we didn't detect a second wall because it was out of reach? Then what we can do is draw a debug line. We're also going to return false. But in this line, we're actually going to say draw a red line. We're going to draw a red line, and we're also going to draw it from hit start. Since you're not hitting any location, it's too far away, we're actually going to do this and say trace end location. And this means if you didn't detect the second wall, it's just going to show you a second red line, meaning that there's no wall within reach. And go back and compile. A quick notice before you do the compiling is if you go back into your trapwire.h, I seem to have forgot a syntax right here, just like ending the line, and because I got the error, and I can take it out and try recompile. Sorry, one more thing is I seem to have made a mistake here. It should be E, simple spelling mistake. And once you fix this as well, and you can compile now. Alright, once it's compiled, you can open your blueprints and make sure everything is there. Make sure you have bounce distance, and if you don't have bounce distance, you might have to delete this and just do the same process I told you before about recompiling and retrying. Because sometimes, even though you have no errors, it might not compile. It might not update the blueprints properly. So I'm going to go back here and see. And as you can see, now I have distance for both of them, throw distance and bounce distance. And if I actually press play and press C, there you go. You can see that whenever I do scroll across, it's facing the direction that the wall's facing. And it's a red color, meaning there's no second wall to detect. But if I go here, it's blue. Both lines are blue because it has another wall to detect. And if I go up here, it's red. Here, it's blue. So basically, we completed detecting two walls. Now what we need to do is basically update the locations. So we're going to get the locations that we detected, and we're going to save them. Because we need to save them because we need to later pass on to the traps to set the location of the traps. So before that, we need to first make the traps themselves. So on to the next part. Thank you for watching, and in part 2, we'll be creating the trap. Like, share and subscribe if you enjoyed.